Chapter 5.3, Factoring Polynomials. Alright, step one is look for the greatest common factor, and that is something that students tend to forget about, but with the method that I'm going to teach today, it's very important to do that. That might be something like you have 3a squared minus 6a, and you're going to factor out the greatest common factor. Factoring is like division. You see what these two terms have in common. They have a 3 in common because 6 is just 3 times 2. They also have an a in common. Remember that a squared is just a times a. So the greatest common factor is 3a. And then we are going to put parentheses for what would be left over when we factor it out, or it's like dividing it out. So 3a squared divided by 3a is going to be a. Think about multiplying them back together. 3 times 1 is 3, and a times a is a squared. Then for the second term, you have 3 divided by 6 is 2, and a divided by a is 1, and then the minus sign is there. And you could check your factoring, and because it is the inverse operation of distributing or multiplying. If I did this, I would get the 3a squared, and then I would get 6a when I multiply 3a times negative 2. So that's factoring out the greatest common factor. Okay, step 2 is going to be look for the difference of squares case. Now, difference of squares case will have only 2 terms, and they'll both be perfect squares. The result of a squared minus b squared is a minus b times the quantity a plus b. And you could check that by multiplying. So I've drawn a multiplication box over here, and on the top I'm going to put an a and a b to represent the a plus b, and on the side an a and a negative b to represent the a minus b, and it doesn't matter which one I put on top and which one I put on the bottom. So multiply a times a in this box and we get a squared, multiply a times b in this box and we get ab. A times negative b is negative ab, and then a negative b times b is negative b squared. ab minus ab, or added to a negative ab, becomes 0 and it cancels out. So that leaves me with just an a squared minus b squared. So that is our difference of squares. If you did not want to draw the box, then I might do something like this. There's your a squared. Here's your minus b squared. And here's your negative ab. And here is your ab. Now, remember the smiley guy? The sum of the nose and the mouth of the smiley guy, when drawn like this, is going to be like terms, and they will cancel out in this particular case. Alright, some examples to try. Now, for the first one, you're going to look for the greatest common factor. There's a 2 and an x. 10 is divisible by 2. There's an x in every single term. So the greatest common factor is 2x. Then you put parentheses for what's left over, and you do 2x squared divided by 2x. Now I'll just show this one time, but here's a 2x squared, and this is expanded notation. And then we're going to divide by 2x, and then 1 times x. So if that made sense to you, you like that, you could always use expanded notation. 10x divided by 2x, that would be 10 divided by 2 is 5, and x divided by x is 1, 5 times 1 is 5, and then the minus sign. And if you wanted, you could check, but if you distribute, you will get this back. Alright, this one here, there's no greatest common factor, so are we done? No, in fact, because there are 2 terms, and it is a difference, just like in that one, but these are both perfect squares. 1 is a perfect square because 1 times 1 is 1. So the rule was a squared minus b squared is equal to the quantity a minus b times the quantity a plus b. And it doesn't matter what order I write those 2 factors in. Last time I probably wrote them in the other order. No, I didn't. I wrote the minus first both times. Okay, so the x is like a. and the b is like a 1. So what you want to think of is square roots. The square root of b squared is b. The square root of 1 is 1. So I'm going to put a minus and a minus, a plus and a minus, either order. There, I switched it up. It doesn't matter what order. You have the plus sign there or the minus sign. Whichever sign you have here, it's the opposite sign there. All right, example 3 is a little bit more tricky. It doesn't look like a difference of squares, but it will be, because you have to do step 1 and step 2. Like the blue one, example 1, just as an example of greatest common factor, and example 2 in red is just an example of the difference of squares. So this one, you look for a greatest common factor, and there is a 3 that you can factor out, and you're going to factor or divide that out of 27. 27 divided by 3 is 9. I'm not factoring out any x's this time, so there's an x squared completely left over. And then 3 divided by 3 is 1, not 0, folks. Don't make that mistake. Okay, so now this is a perfect square. 9 is a perfect square. Anything squared is a perfect square, and just like last time, 1 is a perfect square. So you think square root. The square root of 9 is 3. The square root of x squared is x. The square root of 1 is 1. So there's my a minus b, and my a plus b will be identical, except for the minus sign will be a plus sign. Bring down that 3. It is part of the complete factorization. So there we go. Okay, you try this one. Look for greatest common factor. Look for difference of squares. (49) is not divisible by 4, but there are x's in both the terms, and in fact there's one x here, and there's at least one x there, because that's xxx. So I have a greatest common factor of x, and I'll be left with a 4x squared minus 49. So the greatest common factor step is done, and this is a perfect square. 4 is a perfect square, and the square root of 4 is 2. X squared is a perfect square, and the square root of x squared is x. And 49 is a perfect square. The square root of 49 is 7. So bring down the x as the greatest common factor, but let's not forget the identical factor with the sign that is different than this one. And we're done. All right, so step 3 and step 4 are going to be the x in the box, but there is a lot to explain here. Take a look at x squared plus 7x plus 12. It's in the form ax squared plus bx plus c, which is standard quadratic form. So the ac, it means do a times c. Now in this example, a is the coefficient, the multiplier of the x squared term. A is 1. So I'm going to write that here. A is 1. B is 7. It's not 7x, it's just 7. And C is 12. So I'm going to write the product of A and C here. A times C is 12. And up here I'm going to write just B, and that's 7. Now the new terms, or the new numbers that I'm going to put in this x, they are going to multiply to be 12 and add to be 7. So what I'm going to do is I'm going to put all the factors of 12 as pairs over here, and don't worry about whether they're positive or negatives. Just like 1 and 12, 2 and 6, 3 and 4, and that's all I'm going to write, because if I kept going it'd be 4 and 3, which is just a repeat because the order doesn't matter in this procedure. So we need them to multiply to be 12, and I'm looking at things that multiply to be 12. I need them to add up to be 7, and that means the 3 and the 4. So the 3 is going to go in one of the spots, the 4 is going to go in the other, and it doesn't matter which is which. Okay, over here to this box. Alright, a couple things I want to point out here is that the first term is the first term of your ax squared plus bx plus c, your polynomial, and it will include the x squared. So that's going to be x squared written in this box, and same with the last term, and it comes from the polynomial. It will just be c. So this is going to be like an ax squared, and this is going to be c. And then for the new, they're going to be borrowed from over here, but look at that x. It says we're going to put an x in there. So that's a 3x and a 4x. Okay, so we're mostly done. We're going to have our answers pretty soon to factoring this polynomial. So what we're going to do is we're going to look at the columns and the rows of this box, and we're going to find the greatest common factor of each. And we're going to list them here. I'll put a little spot here, here, and there. So the greatest common factor of x squared and 4x is x. And we don't actually have to do the factoring, just list the greatest common factor out here. And for 3x and 12, it's 3, because 12 is divisible by 3. And here, the 4x and the 12, it's 4, because 12 is divisible by 4. And here, it's x. Okay, so we're looking at x and a 3, and that's going to be an x plus 3. If there was a negative there, then that'd be minus. So x plus 3 and x plus 4. We finished our first example, but we're going to need more than that. We need some practice in order to get this. All right, 15x squared plus 8x minus 12. A is 15. My first term is 15x squared. My last term is negative 12. Do include the negative with it. My a times c, well, let's finish this over here. B is 8. So the 8 goes here. The c is negative 12. Again, include the negative with the and then a times c, 12 times 15, 180. But it is a positive times a negative. So negative 180. Alright, so factor pairs of 180 might be kind of difficult. So I'm going to go over some of the tricks that I showed you on the graphing calculator. And I know we haven't used this one, but we're going to go Stat and Edit. And we're going to put in list 1 a bunch of numbers. Say, let's go 1 through 10. Alright, so we are going to go 180 divided by list 1, and list 1 is a second function right here. And then hit the down arrow and it'll calculate 180 divided by 1. 180 divided by 2, and that's 90. So if you don't get a decimal, then you have found factor pairs. And we're going to look for factor pairs where we get this 8. And we have to, you know, how I said it could be a sum or a difference. It's a difference if you have a negative right here. So we want a difference of these two to be 8. And we could scan through there and see which one that is. Or we could just repeat the trick a little bit. Go over here to list 3 and let's go list 2 minus list 1. Second 2 gives me list 2 minus second 1. Now as soon as I hit the down arrow, I'll never get to see this again. But it will calculate this. And I'll show you. I go up there and it tells me all the elements that are in that list. It doesn't tell me how I got them. So I'm going to look for a difference of 8, and I found it. 10 and 18. So 10 and 18 are my factor pairs that are going to work for this. And I'm going to put a 10 here, and I'll put an 18 here. Now one of those has to be negative. They have to add up to be a positive 8. So if I add an 18 to a negative 10, that'll do the trick. Alright, I'm almost done. So put one of those new numbers here, but with an x. Remember, with an x. And put the other one here. And then we are going to find the greatest common factor 4 times, write our answer, and we're done. Okay. 15 and 10 has a greatest common factor of 5. X squared and x has the greatest common factor of x. 18 and 12 has a greatest common factor of 6, because look, take the lower number and just do factor pairs. We've already done this one, really. 12 and 1, well, 12, no. 18 is not divisible by 12. 6 and 2, 18 is divisible by 6, and it was the largest number I'm going to come up with. And no x there, and it's a positive, so plus. Now, how do you determine if it's a positive or negative? Depends on the sign of the term that's right on that box, right on the border. So that negative 12, that negative won't contribute to the greatest common factor, but this negative 10 It will. So I will have a negative for this one. So I'm going to have a negative, and 10 and 12 has a greatest common factor of what? 2, because 10 is just 10 and 1, 5 and 2, and 5 is not a factor of 12. So negative 2, and then no x there. Let me get rid of those underlines here, because whenever we're dealing with negatives, those dashes might get in the way. All right, last one. So greatest common factor for the 15 and the 18, what is it, 3? Because 15 is 5 and 3, and 18 is not divisible by 5, but is divisible by 3. And then for the x squared and the x, we've got an x. So for the factor that runs this way, vertically, I've got a negative 2, so I'm going to write it as a minus. So 3x minus 2 and 5x plus 6.